Okay, everyone. Thank you very much for joining. We're going to get started now. People are still showing up here, but we're going to get started since we have a lot to go over and only about an hour to go through it. So, my name is David Politis. I'm the founder and CEO here at Better Cloud, and I'm really excited and thrilled to be welcoming all of you to the first ever Cloud IT Live event. I think some of you have probably come to our events in the past, and over the last several years, we've actually done dozens of online events. We've had tens of thousands of attendees, and we've been thinking about, we actually contemplated doing this specific event in person, and you know, we thought about putting it together here in New York, but we decided just the time, you know, travel is very time consuming. Getting budget for these kinds of things can be challenging, and so we decided that we were going to do this in you know, over an online event. And you know, we just, my personal belief is that this kind of information it should be really you know, available to everyone, and really, especially when it comes to IT, I don't think there's anyone out there putting any kind of information at this level out there for free, available to everybody, online. So I'm very excited about this event, and we've been working on it. Our team has been working on it for the last month, getting amazing speakers. So over the next 2 days, you're going to hear from some of the most innovative IT professionals, people from BuzzFeed, Essence Digital, State of Colorado, and I want to thank all of the presenters, the panelists, the moderators. They're taking a lot of their time to present this information. So I really appreciate that. And my goal for everyone is to walk away with 1, 2, 10 strategies, tactics, things that you can actually go back to your organization and try, things that are actionable. I find a lot of webinars, a lot of events, generally you walk away and you say, what did I actually learn? What can I actually do with this information? And so for me, I hope that over the next 2 days you walk away with something, at least one thing that you can go back to your organizations and try, something that you can share with your team. So I think everyone knows this at this point, but this Cloud IT Live event is presented by our new online media property, the Better Cloud Monitor. If you haven't been there, bettercloud.com/monitor. We share stories, tips, best practices for IT professionals and really anyone that interacts with technology on a daily basis. We're very proud of this new media property. It's something we launched about 2 months ago. The content is amazing. The articles are amazing. So I suggest you check that out. So with all that being said, no one's really here to hear me speak. We're here to hear David Otter from MIT. He's our keynote speaker today. And just quick story about how I had the idea, we got the idea to have David come speak, is that earlier this year I was listening to an episode of the Freakonomics podcast. If you don't listen to that podcast, if you haven't heard it before, I do strongly recommend it. And David was one of the guests on the podcast that I was listening to. Literally, as soon as I finished listening to the podcast, I sent the link to a bunch of people on my team, told them they needed to listen to it, and said, we need to get David in front of our community of IT professionals. And that's when this started. I reached out to David. We spoke on the phone. He agreed to join us today. I'm really excited about this. And you know, just in case you know you're not excited to hear David speak from that intro, he received his PhD from Harvard, and he's now a professor of economics at MIT. And so we're really excited, and with that, I'm going to turn this off to David. And by the way, if you have questions throughout the session, please go ahead and ask them in the GoToWebinar question app there. There's a little section of the GoToWebinar app where you can ask questions. So if you have questions, please go ahead and ask them there. And at the end, I'm going to be giving those questions to David, and he'll be answering them at the end of the presentation. So without further ado, David Otter, thank you very much.
Thank you very much. It's a pleasure to be here. You can hear me okay?
Yes.
I'm going to say those. Yes, great. So it's a pleasure to address this audience, and I'm looking forward to your questions at the end as well. I'm going to try to speak for about 25 minutes, half an hour, and then hopefully we'll have time to talk. So the subject that I'll be speaking on is why are there still so many jobs, specifically after 2 centuries of very rapid automation, why are we all still working? And I'm going to try to put that question in historical perspective, and then I'm going to walk it forward and try to project a little bit. So let me begin. There we go. As you're all aware, we are in an era of automation anxiety, an era in which many people are making somewhat nervous or even catastrophic predictions about the way automation is going to make us superfluous. We could be racing against the machine, we might be losing against the machine. The rise of the robots portends potentially a jobless future. And these are books written by entrepreneurs, they're written by economists, they're written by historians. And so I think the sort of the general level of concern around this issue is extraordinarily high. So just to let you know what I'm going to talk about, first, these concerns are not new. In fact, we've been experiencing them at some level for at least 2 centuries. And in those centuries, they have come and gone with greater urgency. And I'll talk about a couple of previous episodes to give you a sense of that. And in those 2 centuries, it's understandable why people have been talking about this topic so much, because we've actually had 3 different technological revolutions, one being the Green Revolution, the second being the Industrial Revolution, and the third being the Information Revolution, which we're undergoing now. Then I want to try to answer in a focused way, well, why are we all still working, given that so much of what we used to do has been automated? Then having tried to answer that question looking backward, I'm going to try to answer it looking forward as well and talk about a little of what might be ahead. I do not mean to claim great expertise here. I'm not a computer scientist, but I have a sense of some of the economic forces and some of the technological forces, which I'm sure you understand better than myself. Finally, I want to talk about the what I think as the skepticism that you should view some of the more dire predictions, and particularly the Singularity being an example of one of them, the idea that we're approaching a threshold where machines overtake us and leave us very far behind. So that's the preview. So let me start talking about automation anxiety. So the example that you've probably are all familiar with, or at least have heard in passing, is the Luddites. The Luddites were 19th century weavers who rose up against the power frame, which was basically an automated loom or partially automated loom, and destroyed a good number of them. And they took their name after a fictitious Ned Ludd, who was an inspiration to their cause. And the term Luddite is always used pejoratively. It means someone who irrationally fears technology. But not everything that the Luddites were afraid of was irrational. And as I flip to the next slide, you'll see what they were afraid of, which was that their finely developed skills over many years or decades of experience were basically being made superfluous, and what was replacing them was a lot of sophisticated equipment and children. And in fact, the typical textile mill worker in Manchester in the 1800s would have been an indentured child, somewhere between the ages of maybe 8 and 18, an orphan or someone who had been given, a child who had been given to indenture by his or her parents, and basically the main skill they had was not expertise in weaving, but dexterity. They could work quickly with their fingers, which was pretty important. People lost a lot of fingers working with those machines, and willingness to work extremely long hours at effectively extraordinarily low rates of pay. So the weavers, in fact, had a point. Where were they right and where were they wrong? Well, they were right in worrying that the machines did directly compete with them and potentially devalue their skills. Where they were wrong was foreseeing this as the sort of the end of work and the end of labor's prosperity. In fact, just the opposite occurred. Why did that occur? Well, for one thing, the Industrial Revolution, or taking weaving as a specific example, led to a period where people could actually afford a change of clothes. People became materially much wealthier because fabrics and textiles became a great deal cheaper. In addition, the rising demand for fabrics and textiles as a function of the innovations and its falling price created a lot of employment, both for workers in textiles and more broadly for the people who made and tended the machines and the innovations that followed. So it was absolutely disruptive, and in many ways made a subset of people significantly worse off. However, in aggregate, it was a very good thing, and this is generally a broad story about how technological change tends to occur. Let's fast forward to another episode of concern. In 1964, President Johnson established the Blue Ribbon National Commission on Technology, Automation, and Economic Progress, and they were there to address the productivity problem of 1964. You may be surprised that the productivity problem in 1964 was that productivity was rising very rapidly. And now I know you're thinking we should all have such problems, but the concern at the time was that after the Great Depression, starting in 1929, there was essentially insufficient demand in the United States. Prices were extremely depressed, whether for agricultural goods or industrial goods. And the U.S. never really came fully out of the Great Depression until the start of the Second World War, when there were enormous, through the enormous coordination and investment of the federal government, basically almost all U.S. industrial activity was turned over to wartime production. And when the war ended, there was a concern that we'd go back to a period of slack demand, and where there just wouldn't be sufficient consumer buying power to raise prices to a level where people could make a living based on their own work activity. And that became very evident in the early 1960s. So you see this picture in front of you, the Milwaukee MATIC industrial machine tool, which is one of the early computer numerically controlled machines. And you can tell it's quite a sophisticated piece of hardware because the guy operating it is wearing a lab coat. And the concern there was that we were just gonna run out of jobs. Now, the commission, the Blue Ribbon Commission, ultimately concluded that there wasn't that much evidence that that we were running out of jobs, but they said we should keep our eyes open, keep our eyes on it. And of course, as you're well aware, the period from the end of the Second World War up until the mid-1970s was one of the periods of the most rapid, remarkable economic growth in world history. That was the best era of U.S. innovation, or at least of U.S. rising standards of living in any time recorded. Just as a sort of a side note, the U.S. Department of the Interior in 1974 wrote about the leisure crisis, thought by many to be the epitome of paradise, could become a perplexing problem of the future. You may ask yourself, why was the Department of the Interior writing reports on this? Well, the answer is that they run the national parks, and so they're going to have to deal with all these leisure-crazed Americans not knowing what to do with their time, presumably overrunning Yosemite and Yellowstone and all the other parks. Okay, so let's talk about what actually happened. During this period, when people on repeated occasions were deeply concerned about automation reducing employment, actually the opposite occurred. So you can see the labor force participation of men from 1890 to approximately 2014 has come down somewhat. It's been steadily trending downwards since the 1950s. But that's not altogether a bad thing. Many people work, but then they're able to retire now, and if they're ill or they reach a ripe old age, they don't have to work until the day they die. Meanwhile, women have moved from grueling unpaid employment in the home to generally more rewarding and remunerative and intellectually interesting paid employment in the labor market. So the fraction of all adults who are working has risen considerably in this 120-year period. Now, of course, it bears emphasis that people don't work nearly as many hours as they used to work, so there's more leisure than there used to be. People don't typically work 16-hour days, 7 days a week, but that's a good thing. That means that we've taken some of that rising wealth as a result of our rising productivity and turned it into leisure. But it hasn't meant a very large rise in involuntary unemployment. In fact, just the opposite has occurred. So now let me try to talk about, well, how did that take place, and walk you through the kind of 3 technological revolutions behind it. So this figure shows you from 1840 to 2010 the distribution of U.S. employment across agriculture, industry, which is manufacturing plus sort of primary production, mining, and so on, and then services, which is everything else, everything from software to hospitals. So you can see, first thing to note is agriculture by far was the largest employer for most of human history after agriculture was invented. So in 1840, 68% of employment was in agriculture. In 1900, 40% was, and by 1950, that had fallen to 11%. Why did agricultural employment fall so fast? Well, no surprise about that. This figure shows you even in the recent era, in the last 60 years, agricultural output has increased by approximately 150% between 1950 and 2010, with no increase in land, labor, energy, water, or seed being used in agriculture. That's all just pure productivity improvement. And that productivity improvement, in the short run, created wealth and allowed people to produce more output. But in the long run, there's apparently a finite amount of food that Americans can consume, all evidence to the contrary. And so eventually, they're just, as productivity rose, less and less of our resources had to be devoted to producing food. And so employment fell. And so, when you think about the thing that the Johnson administration was concerned about, this idea of rising productivity leading to falling employment, it can happen. It can happen in specific sectors, and certainly it happened in agriculture. So where did all those people go? Well, the next place they went into was industry, and that means making stuff largely. And let me emphasize that that transition didn't happen automatically. A very important part of that was education. So farmers in the 1880s recognized that agriculture was contracting, and that there would be that their children would be much less likely to be working on the farm than they would be, and they wanted to do something about that. And what they decided to do about that was to invest in their children's education. And the U.S. was the first country in the world to send its entire young population to high school, to create a compulsory education law system that went all the way through secondary education. And the states that led that so-called high school movement, this was not done at a federal level, it was done state by state, were the farm states, because they were keenly aware that their children were going to have to be making a big change. That decision at the time was considered radical. And many other of our European friends looked upon us as being somewhat frivolous and quixotic in making this huge investment. They thought, A, why does everybody need this elite education where they can do math and read and write? That seems excessive. And B, can we really be confident that most children are really capable of learning on that? Maybe that's that's just a step too far. Anyway, it turned out to be one of the most forward-looking and important decisions the U.S. made. Probably one of the reasons the 20th century was the American century is because we had the most skilled and flexible workforce. So as we talk about the next wave of technological progress, that was really the Industrial Revolution. And just to put that in front of you in a very concrete way, here is a picture of the Ford River Rouge plant in Michigan, and this is a factory where literally at one end iron ore would go in, and that would be turned into steel, and at the other end of the factory would come out Model T. So this was basically completely integrated production, and this was a remarkable feat, as I'm sure you're aware, to be able to take to make machines, instead of making them one at a time by hand by individual artisans, as was done formerly with fabrics and textiles, now to make them with interchangeable parts, with thousands of people working as a group in a series of steps, all organized and coordinated. And this was initially created enormous demand for less skilled labor. People didn't have to be trained craftsmen to work on cars. They just had to follow simple steps. But of course, simultaneously boosted demand for people who could maintain machines, who could engineer and oversee the production process. But it was an enormous advance, of course. But what many people are not aware is that the height of U.S. manufacturing employment as a share of all employment was right at the end of World War II. It was 39% in 1943, and it has been falling decade over decade since then. So already by 1969, it had fallen by a third, from 39% to 26%, and then by 1989, fallen to 17%, 2000, 13%, and then there was actually a very steep drop in the early 2000s with China's dramatic penetration of world manufacturing. So again, we see this phenomenon of rising productivity leading to potential prosperity, but simultaneously in the long run, likely leading to reductions in employment in that sector. Some of that is due to trade, but a good chunk of it is simply due to rising productivity. So that brings us to the next industrial revolution, and that's the IT revolution. And as people have moved out of industry, they've moved into services, and services are much more information intensive, and of course the most critical technology behind information intensive activities, at least in the last 50 years, has been the computer. So let's talk about a computer. So let me put up a picture of a computer that you may not have seen recently. This is the Jacquard Loom of 1801, considered by many to be the very first commercial computer. Now, what makes it a commercial computer? Well, what you can see, of course, is that it's a loom, meaning, again, used for making fabrics, but it's a loom that's driven by punch cards. These brass plates in front of you have a series of instructions that tell the loom what steps to take, what arms to lift, what threads to use. And those instructions are not coded as pictures of what the fabric is supposed to look like. They're symbolic codes. So what makes the Jacquard Loom the first computer is that it's actually a symbolic processor. You establish a language of commands. They can be encoded in a variety of different symbolic forms here on brass plates, and then the machine decodes those instructions and carries them out. So in fact, it's executing a program. And the Jacquard Loom was actually quite an original and important idea. So the punch card idea was adopted by Herman Holroth, who invented the paper punch card, similar to the brass one. It was used to read the 1890 US Census. That was the first machine-read census of populations. And then Holroth got together with Thomas Watson to form IBM. So this computer that you see in front of you is in many ways a very close relative of the contemporary computer, in the sense that it's a symbolic processor. It acts on stored instructions. It executes a program. For it to do something useful, you have to write the program in a way that allows the machine to autonomously carry it out. It doesn't have any common sense, doesn't have much flexibility. It just carries out instructions. But if you're able to do that, it can do it rapidly and accurately and with enormous precision. So what has changed in the 215 years since the Jacquard Loom in computing? Well, the biggest change actually is the cost of computing. So this figure from a paper by Bill Nordhaus at Yale University, economist, tries to calculate the real cost of doing 1 million standardized calculations from 1850 to 2010. So in 1850, of course, that would all be done by paper, or probably by quill and papyrus, then later by abacus. There was a Burroughs 9-adding machine. But basically, from 1850 to around 1940, there was no decline in the cost. And the reason is, although there were some technological advances and there were more people around who were skilled, wages were rising. So if you wanted to pay someone to do a million calculations, it wasn't getting any cheaper. Then, of course, in the 1940s, we entered the early computing era, first the vacuum tube era, and then the transistor era, and then the integrated circuit era, and then the microprocessor era. And in that time, the real cost of calculating a million instructions fell by approximately 2 trillion-fold. So this is a logarithmic scale, I'm sure you've already inferred. So each step down is dividing by 10 again. So at this point, the cost of doing a million calculations is practically zero. In fact, even while I've been talking, your phone in the background has probably executed several million instructions that you're not even aware of. So that's an amazing fact, and it creates an enormous incentive for substitution of computing machinery for people. Because if you've been using people to do something, and then there's a piece of machinery that can do it, and guess what? It's suddenly fallen by 2 trillion-fold in its cost. That creates a very strong incentive to figure out ways to replace expensive labor with cheap and reliable capital. So why are there still so many jobs? Well, I'm going to let me make a bold argument here, or at least probably an incorrect argument, but nevertheless bold or a broad claim here. I think there's a very fundamental reason why machines are not doing most of our jobs, and that is that we don't know how to program them to do those jobs because we, in fact, do not know how we do them. So the scientist and philosopher Michael Polanyi wrote a book in 1964 called The Tacit Dimension, and he made this point: we know more than we can tell. And by that he meant that there are many things that we do effortlessly that we don't effectively know how we do them. So for those of you who have children, you know that you can teach your children how to do addition, subtraction, algebra, multiplication, and so on, because those are explicit codified procedures that we have invented as a society, right? They're formal tools. But you also know that you can't really teach your child how to walk, right? Your child can walk because there's onboard equipment that has sort of, through the course of evolution, worked that out. But if you actually had to teach your child, sit them in front of a blackboard and explain walking, you couldn't do it. The way you teach your child to walk is you basically hold their hands as they master this. Similarly, if you had to teach your child how language works, you couldn't do that either, presumably, because language is, again, something that we do based on our tacit understanding. It basically uses hardware that's built in, but we don't know the procedure. And that means that it's very difficult for us to write a program to do the same because we don't explicitly understand it. So I can easily, or you could easily write a program to play chess, but you couldn't easily write a program to make a persuasive argument or think of a creative new idea. So this paradox that we know more than we can tell has really two implications, one technical and one economic. So the technical implication is very straightforward. You can't automate what you don't explicitly understand. The economic implication is much more subtle, which is that tasks that are not directly substituted by machinery are often complemented by machinery. And I'll explain what I mean by that in just a moment. So let me start off by talking about the substitution. So this figure shows you the share of employment across, the percentage of change in employment, so employment growth, across three broad categories of occupations between 1979 and 2010. And these occupations are ordered from lowest paid to highest paid. So on the left you have personal services, personal care, food cleaning, protective services, and these are jobs that don't require much formal education. You can be productive in them very rapidly. However, they require the kind of dexterity and flexibility and sightedness and common sense that's extremely hard for us to automate. Or I shouldn't say us, extremely hard for you to automate. And noticeably, those jobs have been growing. They've been growing pretty rapidly. And an important reason why they're growing is because as our population grows and as we automate more stuff, these jobs tend to hang around. These are the jobs that actually, in many ways, fit Polanyi's paradox that we don't know how to do them. If you look at the next group, operators and laborers, production workers, office administrators, and to some degree sales, these are jobs that are in many ways codified. They follow explicit rules and procedures. So if you think of what a secretary used to do, was typing and filing and copying and sorting and so on, or you think of what many production jobs used to be, which are basically repetitive motion activities, these are things that actually readily can be programmed, or increasingly so, and not by coincidence, they have been declining as a share of employment. Those middle skill activities, although generally they require more education and more formal training than the things on the left, they also look more like the things that the loom did, and hence are more likely to be automated, and increasingly are. Then if we look to the far right, technicians, professionals, and managers, these are jobs that require expertise and creativity and flexibility simultaneously. So you can't be a good doctor simply by behaving like an automaton. Similarly, you can't be a good computer programmer if you're just a machine that spits out code. The real art of it, of course, is in the creativity and the originality and in the innovation. Same way in management. So interestingly, these jobs are difficult to automate, and not only are they not replaced necessarily by technology, they're often augmented. They're augmented because if you're a technician, if you're a professional, if you're a manager, access to processing power and information increases the value of your time, increases the quality and the quantity of work that you can do. And hence, when you look at this figure, you can sort of see the two sides of Polanyi's paradox. On the one hand, you can see the direct substitution of codifiable tasks. On the other, you can see the parts that we don't know how to automate tend to grow as a share of human activity. So if you want to ask, so let me be much more specific and say, all right, I'm thinking about how is automation going to affect a specific industry or activity or a specific set of workers. So the first question to ask is, are workers partially or are they fully substituted by machines? Obviously, if you're, if you have a job, if you're a stockbroker working on the floor of the stock exchange, and that stock exchange switches over to purely electronic trading, then you're fully substituted, and you better look for a new form of work. However, alternatively, let's say you're a person who does drafting of engineering drafting, and someone gives you a CAD program. Well, you will spend less of your time, with pencil and paper, erasing and measuring, and more of your time in your, what we would call your area of comparative advantage, meaning using your expertise and creativity to create more ambitious designs or to create the same designs with a great deal more rapidity. So in that type of case, in general, people are going to be, in that latter case, workers are going to be complemented. They will become more productive. The second question is, what skills are required to do the new jobs that are created? So when you think about on that previous slide, on the one hand, the people who do personal services like food service and cleaning, and on the other hand, people who do professional and technical jobs, doctors, and lawyers, and computer programmers, and so on. Those jobs are both difficult to automate, but they differ in one important respect, which is what is the human supply of labor to them. For those personal services, because most people can do them with very little training, you can have enormous growth in that category of employment without much wage growth. And that is what we have seen very strongly in the US over the last 20 years. On the other hand, when you have growing productivity of doctors or IT professionals or people who do research for a living, since it takes years and years to train people to do those activities, growth in their productivity will lead to not just numerical growth in employment, but actually growth in wages, because there's a finite supply at any given point in time. We can't just create a whole bunch of new doctors overnight. The final channel, which is important, is how does product demand respond to growing output and falling prices. So we saw in the example of farming that in the long run, growing productivity in farming ultimately led to declining employment because there just wasn't enough demand out there to absorb all those new products or all the cheap products, and so eventually there was fewer workers involved. But that isn't always or even necessarily often the case. So let me show you a kind of amusing counterexample. This figure shows you employment of bank tellers in the United States between 1970 and 2010, and that is the blue line on the top, and on the bottom shows you the number of automatic teller machines that were installed. So in 1970 that was approximately 0. In 2010 that was approximately 400,000. In that same time period, bank teller employment went from 200,000 to 600,000, and there was significant, not enormous growth. Even from 1990 to 2010, bank teller employment went from about 550,000 to about 600,000. So it's not growing rapidly, but it hasn't fallen off. Now you may say to yourself, gee, I thought machines, ATMs, replaced bank tellers. Why are there still so many bank tellers around? Well, it's an interesting process. What happened was, of course, when banks introduced ATMs, they were able to reduce the number of tellers per branch. They were able to reduce them from approximately, on average of 25 or 20 to maybe 15 or 10 per branch. And so there was direct replacement. However, banks also noticed that now that it was much cheaper to open a branch, they could open more of them. And so banks began branching. So they would install smaller branches in more locations, both with ATMs and a relatively small number of tellers. And simultaneously, they moved into what you would call relationship banking, meaning that the tellers were not simply there to make change and take deposits, but also to sell you other products. So this is an example of where it would seem sort of first order that machines are replacing workers, but even in this case, they're complementing them at another level. They're meaning that the service that the teller provides, which is basically problem solving and doing complex transactions, is complemented by the machine that does the simple and straightforward stuff, like take deposits and dispense cash. And in fact, even when you stop for a minute and reflect on the concern that many people have that we are in an era right now where automation is reducing employment, it's worth reminding yourself that the U.S. has actually added 14 million non-farm jobs since 2010, which is quite remarkable employment growth. Now, not all of those jobs are what you would call good jobs. Many of those are, in fact, those personal service occupations. But that's not about running out of work. It's about whether there are great jobs for everybody to do. And the answer to the one could be different from the answer to the other. It could be that we're not running out of jobs, but certainly some of the jobs that we're creating are less attractive than the ones that we're automating away. And that is absolutely a valid point about the present. Okay, so just to sum up what I've said, why are there still so many jobs? One is that automation makes human comparative advantage more valuable. What we do well is we adapt and we create. As machines replace the quotidian part of what we do, the part that remains for us to do becomes even more valuable. Let me give you a tiny little analogy to make that concrete. Let's say you're baking a cake, or you're a pastry chef, and you make cakes, and the ingredients you need are sort of eggs, water, flour, sugar, and baking soda. And let's say that the price of eggs, water, sugar, and flour all fall. Well, that makes baking soda suddenly much more valuable, right? Because everything else is now in abundant supply, and now this tiny little ingredient that's you just need a little above for each cake is now becomes in high demand because all the other inputs are going to be used more intensively. You're going to make more cakes. Human comparative advantage, in many senses, is like our ability in creation and adaptability is like that. As we get better at automating the routine stuff, the part that we do well becomes all the more central, all the more scarce. Second point is that human ingenuity is vast and often underestimated. If you had asked people at the turn of the 20th century, hey, guess what? 40% of you are working as farm workers today, but in 100 years, only 2% of you will be working as farm workers. What do you think the other 38% will do? They certainly wouldn't have said, oh, software, business services, tourism, air travel, machinery repair. It would have been extremely difficult for anyone to imagine what we would be doing with our time, because many of the activities in which we all work just didn't exist 100 years ago. We have created a whole new set of jobs that require the skills that we have, and not just the jobs, but the services that go with them. All those activities, all that tourism, all those information technologies, all those services and experience, they just weren't around. By freeing ourselves from mundane work, we created an economy that had room and demand for richer and more interesting work. The third thing to remember is that as people get wealthier, they tend to consume more. So the average US worker in 2015 could attain the 1915 standard of living just by working 17 weeks a year. But people choose not to work 17 weeks per year. Why? Well, partly because they want to consume more stuff. They want a bigger house, and they want more consumer electronics, and they want 2 large SUVs, and so on. So people don't work as many hours, but they continue to work, and it's because as we got wealthier, the consumption possibilities also have improved, and so people choose to spend their time in the labor force, not simply sitting at home on the couch. Okay, so let me now, I don't want to talk too long, so let me just talk briefly about where this is headed. I've been looking backward and said, here are the things we can't do, here are the things we can't automate, but you're probably saying, oh, come on, Otter, get with the program. Look at all the things machines are now doing. They're driving vehicles, they're reading legal documents, they're interpreting x-rays. Isn't really these sort of constraints, this pull-on-use paradox, isn't that a thing of the past? And my answer to that is no, but it is instructive to see where are the constraints. And I would say that there are 2 main strategies that computer science and engineering, from my outsider's perspective, are using to face up to the challenge of not knowing the rules for all the things we want to program. I'm going to call those 2 categories: 1, environmental control, and 2, machine learning. So environmental control is the idea that since machines aren't as flexible as people, and that's going to remain true for a very long time, you can remove the need for flexibility by making the environment very predictable. So this, I imagine many of you listening will be familiar with this. This is the Kiva Robotics automated warehouse system. It's now Amazon Robotics. Kiva was an MIT startup bought by Amazon a couple of years ago. And what Kiva does is it turns warehouses into big electronic filing cabinets. And probably many of you are familiar with this. For a long time, Amazon had warehouses that were basically enormous multi-million square foot buildings, unair conditioned, in cheap places, and you had pickers where basically people were, sort of semi-athletes who would run through the building, climb up shelves, grab objects, bring them up to the front. Even today, there is no robot that exists, let alone that's commercially viable, that could do that work. That could replace those pickers, could run through factories and climb up warehouse shelves and so on. So instead, what Kiva does is it eliminates the need for that flexibility. On the one hand, objects come in to the loading docks. They are the robots, which are those orange Hoover-looking things, drive the shelves over to the workers who unload them. The workers put objects on the shelves. They tell the scheduling system what they're putting there, and then the robots take those things and organize them autonomously in the warehouse. As orders come in, the robots again go and collect the shelves. And remember, the robots don't see what's on the shelves. They just know because the software has recorded where each object is kept. And they bring them up to the front of the store to Tim, the human pick worker, who stands there. The robots pull up shelves, laser pointers on the ceiling, point to the objects to be picked. Tim picks them up, inspects them, makes sure they're not water damaged, that they correspond to what they're supposed to correspond to, puts them in a box, and sends them off. So what the Kiva system does is where humans have comparative advantage, which is basically dexterity handling of objects, recognizing objects, that remains done by the worker. All the rest, the sort of the information side and the pure kind of moving objects around side of the warehouse is done by the machine. And this is kind of a paradigm of many forms of automation. So those of you who know how the Google car works well know that the Google car in some sense doesn't drive on roads. Some say it drives on maps, very, very carefully curated maps. And when it arrives in a situation where the maps don't correspond well to what it sees in front of it, it needs to stop. It needs in some sense, it's not as flexible as you are. Let me now talk for a minute about the last component of this, which is machine learning. Again, a term you're all familiar with. If we can't program a machine to simulate a task because we don't know the steps, perhaps we can get the machine to figure out the steps through inductive reasoning, basic idea of machine learning. And there are many great examples of this. So you may, this one may be one you've seen. This is from the Google X lab. This is a few years old now, where the machine was shown billions of pictures and it just organized images into categories, not based on any instruction, but because they appeared to be similar according to its parsing of the data. And this figure gives you a sense that it had actually just picked out a bunch of cats. Now it's also worth knowing, it also picked out what looks to me like a couple of Starbucks mugs in the process. Why did it do that? Well, because it doesn't have as rich a model of the world as you do, and so it doesn't recognize that things that are sort of machine perfect and have purely geometric proportions are unlikely to be living creatures. And this points to a broader question about how to make machine learning truly and deeply effective. So this is a well-known paper from some years ago called "What Makes a Chair a Chair?" And the authors pointed and said, well, imagine you wanted to make a machine learning device that would recognize chairs, so in pictures. So you could say, well, just take everything that has legs and a back and a seat, 4 legs, back, and a seat, and you'll have a chair. Well, if you did that, you would realize that algorithm would not quickly recognize, would miss a lot of chairs that were stools, chairs that were backless, chairs that has 3 legs. So you could sort of broaden the algorithm and say, okay, well, it just needs to have, it needs to be a raised surface, it doesn't have to have a back. Pretty soon you'd get a bunch of tables. So that's not so good. The authors make the argument that when humans think about this problem, they don't simply think about the characteristics of the object, but they think in terms of a richer model of what will it be used for. And so if you look at these 3 potential chairs in front of you, you look at the first one, you say, yeah, I could sit on that. You look at the second one, which is the toilet, you say, yeah, I guess I could sit on that too. You look at the third one, you think, nope, not going to sit there. It's kind of chair-like, but I don't think that would work for me. And the point of that example is that the model that we use, that humans use to work in the world, is extremely sophisticated. Is based not simply on properties of objects, but on an understanding of how all these things interact with one another. And so it's a formidable challenge, and I think the challenge is some way, it suggests that there's a long way to go from simply recognizing cats to actually having machines that can reason about the world. I'm not gonna spend more than another 2 minutes on this. I will say many of you have surely heard of this notion of the singularity, which is goes to the brilliant engineer and futurist Ray Kurzweil, and talks about this moment when machines will overtake us. And usually exhibit A in the singularity is Moore's law, which is the idea that transistor density doubles approximately every 2 years. And this figure shows you that in fact has occurred. Maybe there's been some slowdown, maybe there hasn't, but it's a pretty amazing regularity, and it has dramatically changed our lives. Now, the point I want to make is reasoning from increasing chip density to singularity misses a very important point, which is that very rapid progress in one narrow area often doesn't lead to aggregate progress that's nearly as rapid because there are other constraints. Let me give you an example of that. This figure shows you the median 0 to 60 time of US vehicles that were purchased between 1983 and 2010. So the median car purchased in 1982 took 16 seconds to get to 60 miles an hour. By 2010, the median car only took 8 seconds. So you think, wow, with all that acceleration, we must be getting places much faster than we used to be. But in reality, the hours of annual motor vehicle delay, time spent in traffic, in other words, rose between 100 and 250% in the same period. Why is that? Because there's lots of other constraints. It's not simply a matter of having more powerful vehicles. In fact, the car that I drive has approximately 2.5 times the horsepower that my mom's car that I learned to drive on. But basically I drive it slower because traffic density has increased. So I think that's a very simple way of suggesting that Moore's law you should not reason for Moore's law to the singularity without stopping to think about what else might get in the way. Okay, let me conclude and then take questions. So it's always hard to see where new jobs are coming from. And the process, as I stressed at the very beginning, is disruptive, and it creates winners and losers, just like we saw with the Luddites. In aggregate, it's beneficial, but that doesn't mean every single person is better off. I don't think the question is whether we're going to run out of jobs, but it does mean that we are in an era where we're creating a lot of jobs that don't tend to pay well because the skills that they use are not scarce, and that's a real policy challenge. The singularity is not upon us. You do not see falling employment. You do not see actually incredibly rapid rises in productivity that would also accompany the singularity, nor do the investment data say that we are in an era where there's incredible opportunity of this sort. So I think one can sleep easier if you were worried about the singularity. What if I'm wrong? What if the robots will take all of our jobs? Well, if I'm wrong, that's good news too, because that means that we'll be able to do all the things we already do without actually having to work at them at all. In other words, the machines will do them for us. Now, remember that the machines work for us. They're owned by people. And so ultimately, if the robots in reality took all of our jobs, we would be fabulously wealthy. Now, of course, it would create a different problem. It would create the problem of income distribution. Our income distribution system is based on labor scarcity, that your labor is scarce. If it truly were everything could be done by machines, then it would be that capital that's scarce. And so we'd have to figure out how to allocate who owned what. And that would be a challenge, but it's not a problem of making ourselves poorer through rising productivity. It's making ourselves so wealthy that we don't need work anymore, and then we need to find a way to distribute the fruits of that bounty. So just to end with 2 quotations, going back to the Johnson era in 1964, Robert Heilbronner, a very well-known economist at the time, warned that as machines continue to invade society, duplicating greater and greater numbers of social tasks, it's human labor itself that is gradually rendered redundant. Responding to him in 1966, Herb Simon, who is both a Nobel economist and a computer scientist, wrote, "The world's problems in this generation and the next are problems of scarcity, not of intolerable abundance. The bogeyman of automation consumes worrying capacity that should be saved for real problems." And I would say 50 years later, Simon's critique appears on point. We are not in a period of excess of intolerable abundance. In fact, labor remains scarce and it remains valuable. We have challenges, but they're not the challenge of running out of work. Thanks very much.
Thank you very much, David. That was great. We've got some questions coming in. Actually, you've answered some of them already. There were some questions around machine learning and AI. Read here. So
I apologize that my comments went on a little bit longer than I had prepared.
Oh, no problem. I'm seeing a lot of that. It was a great session. So a couple of the questions, the machine learning and AI, which we covered. There's a couple questions here. Are we going to get the decks after the session? So actually, we're going to be publishing the recorded version of this webinar. We'll be publishing that online and sending that out to everyone afterwards. So just so everyone's aware of that. And then there's another. Here's a question that says, so you mean labor force participation is irrelevant? You mean labor force participation?
No, I don't think it's irrelevant. I think it's relevant because in at present.
Falling labor force. Sorry, you mean falling labor force participation is irrelevant? That was the question.
Oh, I see. Gotcha. No, it's a good question. It's not irrelevant. Over the long run, over the last 120 years, we've seen rising labor force participation, and that's because women have entered the workforce and instead of having to do unpaid employment in the home, and most of the decline in male labor force participation up until at least until 20 years ago was due to rising wealth. There is some reason for concern about recent declines. Some of that is due to population aging, but some of that is due to low educated workers who really face weak employment opportunities. So, at the big picture, not such a concern. But if you look more finely, yes, there's reason to be concerned about less educated adults, particularly people with high school or lower education. And there we see falling labor force participation rates. And that's probably not because there are not necessarily jobs per se, but because those jobs pay so poorly that people choose not to work. They engage in crime. Some of them end up incarcerated. They live off of others, and so on. But that's an issue not about a lack of jobs per se, but a lack of quality jobs. And this is the point I was making about jobs that require human labor, but the labor is not scarce.
So there's another question, actually there's a number of questions about education that have come in. One of them is, what would you recommend for changes in education, content, or method of delivery for our new machine-assisted environment?
Good. Yeah, so education has been historically and will continue to be our best trick, our best thing for preparing ourselves and keeping our skills relevant. So if you did the thought experiment, said, let's say we took the labor force of the 19th century and dropped them in the 21st century, or the 20th, would they be employable? And the answer is many of them would not, even though they have, good character and strong backs and able bodies. Many would be illiterate and innumerate, and they wouldn't be employable. So it's only through education that we've in some sense kept ourselves relevant. What we need now in education are, I would say, a couple of things. The first is doing a better job at K through 12 education. By the time people graduate from high school in the US, they're far less skilled and prepared for the workforce than workers in many other industrial economies where education is done more efficiently and in a more modern way. The second thing we need to do is, of course, send people for meaningful education beyond high school. It doesn't always have to be college. It can be really good vocational training. But we need to do that more effectively, and we need to do it more cheaply. Fortunately, we're in an era where that's possible. For the last few hundred years, there haven't been many breakthroughs in education other than the printing press and the blackboard. Those are big things. Now we have the capability to supplement and augment, and in some cases replace, a lot of labor-intensive instruction with a variety of tools, of ways of delivering content. I don't think that's going to eliminate the need for teachers, but I do think it's going to change the role of teachers. Many more teachers will be facilitators, and you'll have more content that is kind of delivered by canned experts. We're still working this out. I mean, I think there's a lot of experimentation. I don't think there's a definitive answer to what works well, but there's potential for making more education more readily available at lower cost, at greater efficiency, and throughout the life cycle. So fortunately, the IT tools which are requiring us to change what we know and what we do are also giving us a toolkit that will help us accomplish that more effectively over the long run.
Great. So I know that we've run out of time here. I'm
happy to stay another 5 minutes if that's helpful.
Yeah, I mean, just for me, hearing all of this, I mean, listening to your podcast and then watching this presentation today, for me, when we look at IT specifically, and we look at our customers, we look at a lot of the people here in our community that are on this webinar, I see the couple of the comments you made around, automation helping to augment work, helping to get more done, I think that's really what our IT community is going through at the moment. When I think about this paradigm shift that's occurring with the modern workplace and these environments going to the cloud and these heterogeneous environments with dozens of SaaS applications, really the only way that IT professionals can keep getting their job done, in my opinion, and actually making progress in their roles and impacting their organizations on a bigger scale is to use automation, really to complement, augment, to use the word you mentioned, to augment their work, get more strategic work done, do less of the tasks, the repeatable tasks, and automate that and spend the time dealing with this new world, this modern workplace. So for me, that's how I kind of see all of this tying back to what our community is going through at the moment, and I think a lot of what you touched on is just very timely for this particular community. So I just wanted to make that comment because as you were speaking, that was one of the things that I heard. So
if you like, I can comment on that very briefly.
Yeah, that'd be great. Yeah, that'd be great.
I mean, so let me give you an example from my own profession, right? So I'm an empirical economist. I spend a lot of time working with data. I can do, in a half an hour what my thesis advisor could only do over the course of several weeks when he was a graduate student, because computing power has increased so massively. So a lot of time that he would have spent, setting things up on punch cards and so on, I just, hit a command in Stata. This has not made my work less interesting or less rewarding, nor has it reduced the demand for economists. Actually, it's made us much more productive, or at least I hope it's made me more productive. The amount of useful research I can do in the course of a day is greater, and hopefully that additional power allows me to focus on ideas rather than simply rote activities. So, I feel myself to have been greatly augmented by technologies. I'll also say that one doesn't have a choice about these things in the sense that there's a market out there. So let's say I ran a computer company and I said, listen guys, there's all this automation occurring, but we don't want to be a part of that because it means giving up certain activities, so let's just keep doing things the way we've been doing them. Well, pretty soon we would find that our costs are rising very rapidly relative to our competitors. We just can't produce it the way they can, and in the long run we would be kind of wiped out. So it's not optional because there's a market and other people will be doing it. On the other hand, it's also generally makes for better and more interesting work over the longer term that uses human expertise and creativity.
That's great. Well, with that, David, I really appreciate your time today. I'm very happy we got you to come do this presentation. Got a lot of great comments here, people loving it, wanting to share this with their team. So this is great. Thank you very much, everyone. Thank you for joining. Please, I hope you join our other sessions over the next couple of days. We've got some amazing presentations, and thank you very much. Have a great day.
Thank you very much, David. It was really a pleasure and an honor.
Thank you. Bye-bye.